if x plus 2y times dy dx equals 2x minus y, what is the value of the second derivative of y with respect to x at the point 3, 0? So we need to find the second derivative, or d squared y over dx squared. If we're given this function that has dy dx in it, and we need to evaluate that at the point 3, 0. So in order to find the second derivative of y with respect to x, what we can do is implicitly differentiate this function here. But before we do that, we can isolate dy dx by dividing both sides by x plus 2y. If we do that, we'll have dy dx equals 2x minus y over x plus 2y. So now that we have dy dx, we can just take the derivative of this here with respect to x, and that will give us the second derivative of y with respect to x. And since we see some y values on the right-hand side, we'll have to implicitly differentiate. So here's how we do it. Since this is a division of two functions with x and y, we'll have to use quotient rule. So we'll multiply the denominator, x plus 2y, times the derivative of the numerator. So derivative of 2x is 2, and the derivative of y is dy dx. Because we're differentiating with respect to x, and y is actually a function of x, right? So the derivative of that we'll just write as dy dx. We can't just simply say the derivative of y is 1, because y is a function of x, so there might be x values inside. Okay, now continuing on with our quotient rule. So we did the denominator times the derivative of the numerator. Now we have to subtract from that the numerator, 2x minus y, times the derivative of the denominator. So the derivative of x is 1, and the derivative of 2y is 2 dy dx. Dy dx is literally just saying the derivative of y with respect to x. And then dividing that whole thing by the square of the denominator. So x plus 2y whole squared. So now we have this expression that gives us the value of the derivative of y, the second derivative of y with respect to x. What we need to do is find this second derivative at the point 3, 0. So when x equals 3 and y equals 0. So we can go ahead and plug in x equals 3 and y equals 0, but what we need to find first is the value of dy dx at the value x equals 3 and y equals 0. So if you recall earlier, we found an expression for the value of dy dx. So all we need to do is just plug in x equals 3 and y equals 0 to find the value of dy dx at the point 3, 0. So let's do that here. So dy dx evaluated at the point 3, 0 is equal to 2 times 3 minus 0. X is 3 and y is 0 at this point, divided by 3 plus 2 times 0. If we simplify this, 2 times 3 is 6, minus 0 doesn't change it, and then 3 plus 2 times 0, which is just 3, because 2 times 0 is 0. So that means dy dx at 3, 0 is equal to 2. So now we can go ahead, and when we're plugging in our value 3, 0 into dy dx squared, the second derivative, we'll just plug in a 2 for the value of dy dx. Okay, so now let's plug in 3, 0, y value of 0 and an x value of 3 into the second derivative, which is what the question asked for. So we'll have x plus 2y, that's 3 plus 2 times 0, so that's just a 0, so we'll just have a 3. And then 2 minus dy dx evaluated at 3, 0. That's just, we just found that to be 2. So that's just 2 minus 2, which is just 0. And then negative 2x, so 2 times 3 is 6, minus y, which is 0. So we'll just have a 6. And then 1 plus 2 times dy dx evaluated at 3, 0, which is just 2. So 1 plus 4, which is just 5. And then in the denominator, we have x plus 2y. X is 3, y is 0, so this is just going to be 3 squared. Okay, so let's simplify this. 3 times 0 is 0. And then 6 times 5 is 30, so we'll have a negative 30 in the numerator. And 3 squared, which is 9. So this is the value of d squared y dx squared at 3, 0, negative 30 over 9. And we can simplify this. If we divide the numerator and denominator by 3, we'll get negative 10 in the numerator and a 3 in the denominator. So our final answer is negative 10 thirds, which is answer choice A.